Hi there, welcome back. Welcome back to a new series. Welcome back to a new tube radio restoration series. This one is the Philips that you see sitting over here. This particular radio is one I've been looking forward to for some time. This type of radio, this model of radio is the one that is something I've been looking for, and I finally found one. I didn't quite find the one I wanted, but I'll explain in a second. This model was launched in 1963. I was born in 63, so I'm working with something as old as I am, maybe a year older, who knows, but who's counting. This is a B4X23A, and if you know anything about the Philips models, they have a particular way of naming their radios. So if you look at the model number, the first letter B is for benchtop. It could be car radio, it could be phonograph, it could be all sorts of things. The prefix, the first letter changes. And then the number 4 gives you the luxury level. So if you've got a B1, it's cheapy. If you've got a B7 or B8, you really are up there with the really expensive models that came out. So this is a B4, it's somewhere around the middle, and you can see it. You can see it when you look at it. If you look at, if you search for a B7X or B8X, you'll see the difference. Those things are really beautiful. Not that this one isn't, but those things are absolutely fantastic. So this is a middle of the range one, and then it's an X, B4X. So it's the X stands for Netherlands. This was built in the Netherlands. So depending on what letter you have there, you also find which country it was built in. And you can look it up. You look for Philips radio, tube radio codes or something like that. I found this on the web quite easily. And I think I found it on, yeah, I did, on Gerard's Radio Corner. He's got a description of that there. And the A at the end means it's AC powered. It can also be B for battery powered. And there are a few other designators there as well. So this one is the next project. And I've done a few Philips before. I've done one that's actually higher up on the luxury level than this one, the BX750A. There was a biamply, big guy. Really fantastic sound. I'm expecting that the quality of sound is going to be pretty similar to this. I'm not too familiar with the condition of this radio. I should probably look at the listing. I haven't, but we'll find out as we go along. I'm going to open it up. Actually, I'm going to give you a close-up look at this. It's in pretty good condition, although it looks a little bit poor, but the condition's okay. It just doesn't have any flash to it. But then that's the middle of the range. So let's have a closer look at this thing. It's actually a very good looking radio. I like the look. It's something that fits a lot easier on your bench or on a shelf than the bigger ones, but it does have its drawbacks. It has the speakers on the side. So yeah, well, it's a personal choice. But what we have here is a little bit of either they're missing labels or something is not quite clear. Let me show you. First of all, let's go up close and see. We've got a magic eye over there. Now this is a single knob, so this will be just the volume control. Here you've got, oh, it is labeled there. There's the 2 buttons at the bottom, and it tells you what it's supposed to do on that legend over there. We've got the usual display over here, which is in very good condition. That would be just medium AM band tuning and FM tuning. And yes, the dials, I'm not going to have to do any restringing. Thank God for that. Top one's working and the bottom one's working. Good. Okay, brilliant. And over here, we've got 2 more tone select switches, whatever that means. I don't know. What I do notice is we don't actually have a rotary tone control per se. We've got the usual, what is that, on off on the left. We've got K, it's got KOC. K is for long wave, short wave rather, kurz. And OC is on the curta. So this was obviously sold in the Latin countries as well. On the curta means short wave. You've got L for long wave and G, what is that, GO? I don't know what that stands for. M for medium wave and the UKW FM. If you want the gramophone, you push the K and the L together. You can see that symbol over there. So this is a pretty typical sort of Philips faceplate with all the cities on there and everything else, the usual. Now, as for the condition, well, you can see the wood. The wood is in good condition. It just needs some polishing and sanding maybe. Everything's there. There are no cracks or chips or anything dramatic. The side, that side plate, this is where you can see the cost coming in. That's sort of a plastic. It's not wood. But it is in fairly good condition. If you look at the top as well, that is in wood and it's sort of okay. The speakers are out the side, as I said, and this speaker grill again is in plastic. It needs polishing, but it's in fairly good condition. And the back, again, quite usual. We've got our plug over here. This one needs replacing. It's cracked. There's no ground, no earth. I might have to put a earth one on here. What have we got there? We've got the mains coming in. And you've got the voltage selector. It's set to 220 volts, which is good. We've got a strange plug pickup input. That's for a particular type of pickup. And then we've got the tape deck in the middle with a DIN socket. And then we've got the normal pickup, which is just pickup and ground over here. I'm wondering if this thing isn't supposed to be sort of stereo on that plug on the right. But we'll find out. Over here we've got a 5 ohm external speaker connector. There's our label, and this is our antenna. The FM dipole is at the top, the AM is at the bottom. And again, this thing has a whole lot of legends as to how you set it up. If you want to use the internal dipole, I believe there's an internal dipole just for FM and AM. So you can use that antenna for both functions, but usually I put an external antenna on here. Everything is in good shape. The back is in beautiful shape. I wonder what it looks like when we open this up. Let's do that. From the back, this looks pretty normal. When I say normal, I mean normal for a Philips. Philips do have a few different ways of doing things. They've got different types of IF transformers they use. You can actually tell that there's quite a bit of a difference between these radios and the normal. When I say normal, the ones I usually do, the German ones, the Grundichs, Telefunkens, and so on. You can see the concept and the philosophy is slightly different. But we've got some pretty good speakers on the left and right over here. We've got a power transformer, again, very much the Philips sort of wound paper design or construction. We'll also have the Philips caps in here, I'm sure, but yeah, okay. There is I believe that's the rectifier, so selenium rectifier. Intermediate stage tubes, I think that's an EL84 power tube. Tuning condenser for the AM and tuning condenser for the FM. Let's have a closer look. Let's see, we've got, yeah, that's the FM tuning condenser. I'm turning it at the front. And it looks like it's moving. Yeah, this is probably an inductor tuned. It looks like it's moving, physically moving something here which would be holding the inductors that plunge it into the core. The core gets plunged into a coil, and the tuning is actually done with the inductor rather than a capacitor. If you know anything about tank circuits, you'll know it makes no difference really. So FM seems to be inductor tuned. There's a name for it, I keep forgetting. And then we've got the tuning condenser here, which is for the AM. That's a normal one. This would be the filter caps, the rod antenna at the top here, pretty big, not directional, it's fixed. On some of the more expensive ones, you could actually adjust the angle on this. On a lot of the Grundichs and Telefunkens and Sabas, you do have adjustment on the front where you can adjust the angle of the the angle of the orientation of the tuning of the ferrite rod, so you can pick up in different directions. Again, the usual, it is the usual tube arrangements here. We have ECH81 over there, that's the mixer oscillator, an EF89, that'll be an amp. IF amplifier, what is this one? EABC 80, again, very normal, very much like the German radios, the German ones I've done. And that will very likely be EL84, so a normal output stage. And then, of course, we have the selenium rectifier over here, which is, let's see what it is, EZ80. Okay, good. Nothing that's too surprising, nothing that will make doing this thing impossible. As I said, the Philips builds are different to the normal German ones that we're more used to. The concept, the philosophy they use can be quite different. The type of components, the actual tuning coils, or rather IF transformers, look different. The capacitors are very different and sometimes quite bad, but we'll see when we take it out. For now, what I'm going to do is get this thing out of the chassis, get this thing ready for restoration, so we can see what we're facing. Right now, I have no idea. I'm not switching it on. I'm going through my normal procedure, which is check the power supply, then the amp, then the radio sections, and then the alignments and so on. Okay, so let me get this out of here. Well, here we are on the underside. I've taken it out, put it onto that the holders that I use. And what do we see? We see everything pretty much usual. We've got two ground clips over here, which I've got to be careful with because these guys connect to that cover at the bottom, which has got a metal shield on it. So what I normally do, and I'll do that right now, because these things sort of flap around while I'm restoring, it's a good idea just to insulate them. This is not the best insulator, but just insulate them. And that way you won't get a ground connection just flying up into your radio somewhere there and shorting things out. That's not fun. So this gets protected before I forget. Okay, and other than that, what do we see? Well, we've got the FM block over here. We've got not that many. We've got these mustardy caps. I've had both experiences with them. Sometimes they're good, sometimes they're terrible. When they're good, they're all good. When they're terrible, yeah, you might as well remove them all. So I'll have to test them and see what it's like. Other than that, this guy here, this is one of those big black sort of tar-coated Philips caps. There's another one down there. These things are notorious for leaking. They sometimes crack. Bear in mind, this is 1962-63, so they're not as old as some of the ones I've seen. They might be in better shape. But other than that, I see one of those little trimmer caps here. Those things have got wire around them. Never like playing with those. Other than that, what is this guy? There is something that gets pulled. This is odd. Oh, I see. When you pull FM, this is a strange one. When I put it on FM, it pulls that contact away. See that? It just lifts that contact, breaks the switch. That's a contact that's making and breaking there. Well, I suppose it's a switch and it works. Strange way of doing it, but if it works, it works. These guys have obviously seen cleaner days, really dirty, but they're all working, which is a good thing. So cleaning doesn't scare me. It's when there's something else wrong that you might get a fright. Now, there are a few things here that I've noticed. This thing over here was foam. It's now just a powder coating. So everywhere that foam's supposed to go, it has to come out. The output transformer on this guy is on the underside, over here. But everything's pretty accessible. I'm not sure what these resistors are like. There are two types. These are carbon comps. This thing's got a metal shield. You see that over there? That's an insulated metal shield. It goes straight across the middle of a tube. I think that's the... Which one is that? I think that's the EF89. It literally shields the one part of the tube from the other. Remember, some of these tubes have got multiple things in them. You know, dual triodes, diodes, and triode. If that's the EF89, I'm not even sure what that's got. But that thing has got that shield down the middle, and it's also here on the, what would that be, the ECH81 mix oscillator. That is a metal shield across the tube. And the way they do it without touching the two pins just makes it very difficult for you to work on it without touching the two pins, without shorting the pins. But it can be done. I've seen that before quite a lot. So nothing too mysterious about this. I guess I'm just going to get started, get cracking on it, check out the power supply first, as I usually do. I'm not powering this on till I'm comfortable that that has been protected. So let me carry on. Well, it's looking a little different, isn't it? I took it out of the cabinet, put it on my contraption to make it easier to handle. Took the front out. I don't want the glass in there, so you know that's always risky. If you just tap it, you can crack it. So I took that out and I started tracing the supply coming in. And because it passed down the front here, I had to look a bit closely to see where the wires are going, so I decided to do a bit of cleaning in the front. So this section's actually been cleaned. I was bored. And I'm now confident that the switch is working, the transformer is working. I've done a test on that transformer and the output transformer. If you want to see how I do that, I've got a playlist called Building Blocks, Restoration Building Blocks, where I show how to safely test those two components, the output transformer and the power transformer, without actually powering it up. It's always a good thing to do. I've done that, they've passed the test, so as far as I can tell, the power transformer is fine, the output transformer is fine. Everything else, I have no idea. So what I'm going to do is I'm going to put this on dim bulb with one bulb, a 40 watt bulb, very restricted current, and I'm going to switch it on. In fact, what I'll do, the way this switches on is you click one of these, right? You know, whichever one of these you click switches on the power, and you switch it off with that guy. So I'm actually going to switch off the dim bulb limiter, switch this on here, and then I'll switch the whole thing on at the dim bulb, and we'll watch that bulb. I've selected medium wave on there. I've got a speaker connected. Everything looks safe. I'm going to switch it on here. Here goes. Watch that light bulb. It's gone very bright and it is dimming. It's dimming. It's drawing 130 milliamps, 120 milliamps. It doesn't look like a short. Remember, this is a 40 watt light bulb, so it's very restricted. So I expect the voltage to drop quite dramatically. It doesn't look like a short, but it's still staying. Let me try another bulb. If I put this bulb on, I'll have 100 watts on here. Okay, now it's gone down, so there's no shorts. Let's look at the radio, see if we get anything. Volume's on max. Oh, got some noise. Got some crackle. Volume's on max, yeah. The tubes are lit. They seem to all be lit. I'm not sure about that one. That's the ECH81. Can't see the glow. But do we get anything? Absolutely nothing. Oh. What's that? That's shortwave. I put the mini whip on. Let's be optimistic. Can't hear anything except a little bit of hiss. I get absolutely nothing. If I give it, let's try FM. That is not extending all the way. It's jamming over here. I don't want to force it. I'm going to give it another light bulb. I've got 211 volts coming in. Sometimes with low voltage you don't get FM. Nothing. Nothing, nothing, nothing. Well, it was a shot. Looks like I didn't get very far. Let me switch this off. I don't want to risk it. Whatever's wrong with it could just get worse if I leave it on. So what I'm going to do now is switch off the supply completely, and I'm going to check the power supply. See if we're getting B+, see if it's being dragged down maybe by the filter capacitors or any other leaking capacitors over here. I know I'm getting supply. The heater supply is on because that light bulb is connected to the heater supply, and I can see the heaters glowing on the tubes, on most of the tubes. I can't see the CH81's glow because there's actually like a metal shield around it. But yeah, it was a long shot, but I thought I'd give it a try. It's always nice to hear something and then you just keep improving on it. But it looks like this one we're going to have to go by the book. So first things first, check the supply, check the whole supply line, make sure we're getting B+, and that the capacitors, the filter caps aren't dragging it down, and see what happens then. I'll get back to you when I've got something to report. Here we are quite a bit later. I've done a little bit of work, quite a bit actually, but it doesn't really show. What I've done is I've worked on the filter capacitors, replaced the filter caps, and also two capacitors that were across the output transformer, and I want to give it another try. Let's just have a look at the schematic. I'll show you what's been done so far. As usual, I've got the schematic on one sheet. I took the service manual, I created a duplicate, I erased the other pages, and I'm left with just the schematic. And you can see what I've been working on. Here it is on the right. Let me show you from the beginning. So we have the mains coming in here. It goes through the double switch. The on-off switch is a 2-pole, which is great because it means it cuts off the mains completely. It goes through a fuse. This is actually a metal fuse on the transformer itself. And what it does is if it heats up too much, I believe a little blob of solder melts and it breaks the contact. So the supply would be broken. Then we get the first secondary, which feeds the rectifier tube. That's all been checked. The output of the rectifier tube comes out here. It goes to the first filter cap. This is a dual capacitor in one can, two caps in one can. And we've got our first B+. They call it B+++, which is supposed to be 246 volts. At the bottom here, we've got the secondary for the heater supply. And I know this is working because the lamp is going on over here. And the filaments are lighting up. So we know that's working as well. What happens when this thing goes up? Let's see where it goes to. It goes up here. There's the 3 pluses, so it goes into the output transformer as usual. It then goes up and supplies the anode of the EL84 as usual. But it does have two capacitors over here leading off from here. Now what does this do? Well, what this does is it actually bleeds off high frequencies, so it prevents oscillation and it cuts off some of the higher frequencies. This 2.2K, which is 2.2 thousand picofarad, so it's 2.2 nanofarad, that goes straight to ground. And there's another 3.3 nanofarad over here, which is switched in by this switch 5. Now, switch 5, if we look at the switches, this is a little bit complicated. The switching description is not as good as some of the others I'm used to, but 5 I believe is this one here, which is this is the FM. So what it does is it keeps this connected to ground on all the bands except FM. And when you put FM, it removes this, so it gives you more higher frequencies, which is what you expect from FM. So it's basically extending the frequency range of the output for FM so you can get the better quality audio coming through. Those two capacitors were completely messed up. I mean, there are those black tar things, so I'm not surprised, but this one I think measured about 13 nanofarads, and I didn't even measure the leakage. This one measured about 17 nanofarads, and again, I didn't measure the leakage, I just replaced them. And then what do we have? We've got this coming through part of the winding of the output transformer. This is used as an inductor and it reduces the hum. It comes out as B2 plus, so plus plus. So where does that go? Well, that goes in here, plus plus. And this is slightly different to, well, not really. It isn't different. It's actually the same as the German radios. So it comes through a 1K resistor to the second filter capacitor. And the only difference is that you've actually got a supply going off. No, you don't. Again, same story. This is the same. This is your B1 plus. This is 3, 2, 1. I call it the other way around. I normally call this B1, B2, B3. So this would be more filtered. That resistor makes it drop some voltage and also serves as a low pass filter to reduce the hum using this capacitor. And that gets switched off to a B1 plus over here. Can't read what voltage is supposed to be, but it'll be 221 because it's the same as that voltage there. It's just going through a couple of switches. These switches, I believe, what is this, 2 and 3? What is 2 and 3? 2 and 3. Pickup? No. I have not really figured out the logic of the switching. But anyway, it switches it on or off, and that's been checked. These resistors, this resistor is perfectly fine. I have replaced these two. And what I was going to do was just use my little board with the two filter caps that I put on it. But this filter capacitor is used to hold up the rod antenna, the ferrite antenna. And I really wanted to keep it there. And I also thought, well, I need to take it off to clean it up, so I might as well restuff it. So I restuffed this with two 47 microfarad capacitors and put it back. I've done this often enough before. I'll actually link a video above. You can see how I restuff that. And then what do we have? So we would have the supply here. We would have that plus, which is one of those supplies at the bottom coming in here as your screen voltage through that resistor, which checks out fine. And then we've got, I've checked that resistor, checks out fine. And this here is one which is the power switch. So what this does is as soon as you deactivate the power switch, it breaks this connection. And that means this tube loses its bias, which means it stops conducting, which means your audio is cut off immediately. And the reason for that is so that when you do push off the power switch, because the capacitors, these two caps would still hold charge, you would still get some conduction, you would still get some audio going through, so your audio would normally just sort of fizz out. Instead, they cut off the audio immediately just to give you immediate silence. In some of the German radios I've done, this effect is done by shorting this signal here to ground. So as soon as you put off the power, it shorts the audio signal to ground, so there's no more audio to go through. Same thing, different way of doing it. As I said, Philips does have their own way of doing things sometimes. I'm not saying it's better or worse, it's just different, and you've got to get used to it. And I haven't checked anything further, but I wanted to test it again because these guys were so bad. That I've got a feeling it was drawing the voltage down. I didn't test the voltage. I should have tested what that B plus was, but I didn't. But they were leaking so badly, or they were so off, that I suspect they were bringing the power supply down and the radio wouldn't work. So I'm going to try it again. We'll see where we go. So here we are with the radio ready. I've got the dim bulb with a single light bulb, the 40-watt light bulb. I've got a mini whip connected, and I'm going to push, I think this is medium wave. Let's see how we go. Now, I've got the light bulb lighting up. You can see it in the background there. It's going dimmer, which means that there are no shorts. And now I can, it's still only at 174 volts, so it's pretty low. Can't hear anything yet. I'm going to give it another light bulb. So that reduces the restriction. I now have 100 watts in series with this radio. So more current is allowed to go through. Let's see what we get. And we got something. Yes.
Que acaban siendo muy limitantes en su vida.
See that?
Bueno, pues esto les
That's
pasa
a medium
a
wave.
3 de cada 100 personas.
Oficialmente.
Brilliant. That's medium wave. I think this is long wave, which we shouldn't pick up practically anything right now. But it's working. It's picking up something.
مثل كثير منكم أنا ابن مدرسة عمومية علمتني القراءة وعلمتني أيضا أن
That's from North Africa. Let's try shortwave. It sounds like there's nothing up to there and then okay, so it's working. Let's try FM. FM is jamming as I get to there. I can't go further. I've got to see what's doing that. But I should have. Well, I'm actually going to give it a little bit more current because FM sometimes needs a higher voltage. So I'm giving it 200 watts, so 4 light bulbs. Volume's on max. Got something right at the edge there. Good. But I'm not going to push my luck because this thing is still running on pretty old capacitors in there, and who knows what else. But at least now I know that all the bands are working, and the AM bands actually, the medium wave especially, is actually picking up quite well. This is the time of day where you don't normally pick up these AM bands too well, but it's picking up pretty well. And now it makes it a lot easier to go forward because everything you're doing from now on is improving upon what you've already seen. So the other thing I decided to do, and I do this occasionally, I've said that before, I'm busy with something, I get bored or I get stuck, so I do something else that I can do, you know, little treats. And the one treat that I decided to give myself was cleaning up the knobs. A lot of you have asked me on the comments and even on emails how I clean them, what I use to clean them. There's no great mystery. These knobs, look at them, they came out perfectly. They normally are in very good condition. They normally are very dirty when you first get them, but they're in good condition. And what I normally do to clean this is just isopropyl alcohol. I've got a brush. It's a natural bristle brush, which is used by painters, artists, and I buy these things by the half dozen because I go through a lot of them. And it's a natural bristle brush, so it's sort of scratchy, and the texture is just right to clean this with isopropyl alcohol. So I just keep brushing away, loosening the dirt with the alcohol, trying to get some of the grime off with a brush. And then I go into there with a cotton swabs and get to the dirty stuff, the tough stuff that doesn't want to come off with the brush. So I get every little dot, every little speck out of there. And then of course you just rub it over again and clean between the knobs, the buttons, the push buttons. So you've got to clean between them because obviously dirt does get in there. And the result is a brand new set of teeth. This is like somebody's front teeth, and I don't like working on something looking at this all the time. So I'm happy that that job's done. Now, back to the radio. Some of the cleaning here has been done as well. And the reason I'm doing that is I want to be putting the front faceplate back on, but I didn't want to do that without having this section cleaned up. But again, I think I'll probably do a little bit of restoration now instead of cleaning. So the next stage is going to be completing the checks on the power supply circuit. Obviously, B+ goes to all these points. I want to make sure they're getting there. I want to make sure that components on that path are up to standard, up to spec. And yeah, that's basically the format I'm following. I'm following the normal routine, which is power supply line, and then the audio amp section, which I've done part of already. but there's still quite a bit to do. I think some of these capacitors are going to be fine. Most of the caps are these mustard types, and these ones, the experience I've had is they're either all good or they're all bad. So what I need to do is desolder a couple of them, test them for value and leakage on the capacitance leakage tester, and if, depending on how those measurements go, I either leave them all or replace them all. But I've got a feeling they'll be okay, I hope. So yeah, those are, there's 1, 2, 3, 4, 5, probably half a dozen or more over here. There's an electrolytic here, which I think is the FM discriminator cap, but we'll come to that later. These two over here were the two that I replaced that were sitting at the top. They were these guys. These guys are completely messed. They usually are. These tar things. So those have been replaced, and these were replaced with different caps to the ones I usually use. You'll see they're black. I normally use those yellow ones. These were film caps that I ordered from Carl's Capacitors. I've got no commercial relationship with the man. However, I did take the advice that Dave Tipton gives on his channel. He gets his capacitors from Carl's Capacitors, and I decided to give it a try. I actually thought this would not work because I believe they come from Australia. And when I ordered them, I thought I'd probably get them sometime before I retired. But as it happened, it came through quite quickly. I think probably in a week and a half, they were here, which is very fast for Madeira. And so far, so good. They look good. They look like they're more period correct for these radios than those yellow ones. And I've replaced those two, as I've mentioned. That thing under there is the filter can that I had to use some solder because the legs that they twist when they fit the can into the cabinet, into the chassis, broke off, but you can solder them on, and I've soldered all 3 pins on. I've connected it back the way it was originally, so it is very neat. There's no extra space taken up on the bottom, and on the top side it looks like nobody's been there. I mean, see for yourself. This thing looks like nobody's taken it out. If you look closely, you'll see on the underside here there's a little bit of pinching that's visible, and that's because of the effect of bending the aluminium back over the bottom when you cover it up. It doesn't come out perfectly round. There's some pinching visible, but that's something that nobody's going to see. I've got the ferrite rod back to its holder on top, so I know that this thing's got 2 new 47 microfarad at 450 volt capacitors in there. But if you look at it, it looks absolutely original. And that, my friends, is where I'll stop for today. And thank you for your company. So I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now, and stay safe.